Hey guys, welcome to another Sci Teaches video. I'm Simon, and today I'm going to be showing you guys how to do mesh current and superposition. This is going to be my fourth video on this channel for circuits, and it will be the material covered on your third quiz if you are taking this course at Case Western Reserve University. First, we're just going to start with mesh current. Mesh current, you should understand pretty well. Okay, at first glance. So here's KVL. I've just drawn some KVL. You should understand Kirchhoff's voltage law at this point. If I have a circuit that continues on this left side, but is isolated here on the right, so this is like the edge, the right edge of a circuit, and I have I1 flowing here, and I have I2 flowing down, I can instantiate my own current loop, and I can say, well, the sum of everything across that loop, the sum of all the voltages has to be equal to 0. So I've done just that. We go in the negative V terminal, negative V1 terminal, and we get negative V1. And then we add I1 going across this R1 is that voltage, and then we add the voltage drop across R2, which utilizes not I1 anymore, not this, but rather I2 going in that downward direction. And those currents are different because there are nodes here and likely resistors and other components on the other side of the circuit, So, with that in mind, we can now use KVL to understand mesh current. So I've drawn mesh current down here. Essentially, you have two current loops that you can instantiate. So I've instantiated I1 and I2, which you should be able to see here on the screen, right here and right here. And essentially, I1 flows through all of this stuff here and down, and I2 flows through here. And you'll notice there's an overlapping point between them right here, and we're going to use KVL to understand and simplify this circuit. So I know I1's flowing through R1, I1's flowing over here, I2's flowing over here, and the value, the current flowing through R3, I can kind of make an arrow down here, and I have analyzed by KCL, and I encourage you to do this yourself, by KCL, if we're looking at a current flowing down this way, right? So if we're looking at the loop I1, right, there would be a current flowing downwards right here, like there, and that current is I1 minus I2, okay? And the opposite is also true. So if we're looking at the upwards direction, so if we're looking at this upward direction right here, well, that current is the opposite. It's I2 minus I1, because I've got I2 flowing here and a countering I1 flowing this direction. So if I want the current in terms of this direction, it's I2 minus I1, and if I want it in the opposite direction, it's I1 minus I2. And you could also, like I said, use KCL to mathematically show that to yourself better. And here is the mesh current method with that in mind. The mesh current method is, okay, we have loops in our circuit, okay, that we've drawn. Let's analyze each loop using KCL, or using KVL, sorry, and how can we then simplify, right? It's just to give us relating equations. And I'll show you that now with this, not example, but this image here. So in this simple circuit with V1, R1, etc., right, we can first let's look at loop 1. That's I1 up here, okay? Well, we're first going through the negative terminal of V1, so we're going to subtract V1. Then we're going through R1, and it's always the positive terminal. You're always going through the positive terminal resistors. I can't emphasize this enough. Always plus I1 times R1. And then you're going through R3, and because we're choosing to go this direction, because we're going the direction of I1, we're analyzing this loop, this right loop, it's I1 minus I2 times R3, okay? And then we can just quickly look at the left loop as well, loop 2. We have I2 flowing through R2, and that's right over here. We've got than I2 minus I1 flowing through R3, because now we're flowing this opposite direction, okay? We're not flowing in the same direction as right here. We're now going opposite. All right, so, and then the principle is, right, you've got two unique equations relating two unknown variables. That's obviously solvable, so you can proceed from there. So let's go through an example. In this example, we've been asked or tasked with finding all equations to solve this circuit. This may look like a daunting circuit at first. You have 5 loops. It kind of is, but that's why we're just solving for equations. And the first thing you need to do, I've kind of written it in already here, is determine what direction do you want your loops to go in, okay? I've made mine go counterclockwise. And the reason I've done that is because, if you'll notice here, this loop goes in the same direction as this current source here. So I can now already say that I1 is equal to 3, right? I can write that equation for myself. I'll also notice over here I get the same deal. If I make this go counterclockwise, and by the way, all of your loops in mesh current should go the same direction. So they're all going counterclockwise, right? Because one goes counterclockwise, they all have to go counterclockwise. And if I were to choose for them to go clockwise, then they all would have to be going clockwise. But I notice I have the same deal here, where it's going the same direction as this current source. It's really just personal preference, but I find that to be easiest. So yeah, let's get started. The first things I notice before we even do mesh current are, like I said, I1 is equal to 3, I4 right here is equal to 3ix, and then this Vx here is equal to, well, let's look at if we want to put it in terms of Ohm's law, Vx is equal to Ix, the current going through, or not Ix, sorry, the current going through that 8 ohm resistor times the resistance value, because V equals IR, right? So going in this direction, we have, well, I3 is flowing in that direction, right here. And then in this direction, we have I5, right here. And they're countering one another. And we want the overall current going in this direction, going from positive to negative, dropping across the 8 ohm resistor. And that, of course, would then be I3 being positive, going in the same direction here, you'll notice, minus I5, because it's going in the opposite or opposing direction, okay? So I've written that in down here. I1 equals 3, I4 equals 3ix, and Vx is equal to I3 minus I5. I3 minus I5 times 8, you guys, because IR multiplied by the resistor. Now, with that out of the way, we can finally go ahead and analyze our meshes. So let's look at mesh 1 just to start. And in mesh 1, we have, I'm going to denote where I'm starting. I'm going to start right here. So I'll be going through this component, through this, and then through this. Because you can kind of choose wherever you want to start, it doesn't matter. So going through that 4 ohm resistor, we have a current of I1 flowing in the direction we want, and a current of I2 going in the direction we don't want. So that's I1 minus I2. So I1 minus I2 times 4. And then we have to add the voltage of any other components. Well, this doesn't have a voltage associated with it, it's just a current, so we don't add anything. And that has to sum to 0. So now we have a completed equation for the first loop. Let's look at the second loop. The second loop, I'm going to start right here, okay? And that would be, I've got I2 flowing through the right way, I1 flowing through the wrong way, across a 4 ohm resistor, that's I2 minus I1 times 4. Then I'm now here, flowing through the negative terminal of a 2Vx voltage source, and so I'm going to subtract 2Vx, sorry, or add negative 2Vx. Then I'm flowing through the positive terminal, right, or just flowing through a resistor with I2 going in the right direction and I3 going in the wrong direction across that 10 ohm resistor. That's I2 minus I3 times 10. And the last thing, going through this 6 ohm resistor, I've got I2 flowing the right direction, I5 flowing the wrong direction, right, in that 5th loop. So that's I2 minus I5 times 6. And that's the last component there. So that's going to be equal to 0. Then you'll notice I do the exact same thing in the 3rd circuit. I'm going to start right here at this 10 ohm resistor, I3 minus I2, right? I'm just going to emphasize again, I3 go in the right direction, I2 go in the wrong direction. So I3 minus I2 times 10, IR equals V. Then we're flowing through the positive end of that 2Vx source, so plus 2Vx, then plus I3 going positive direction, minus I4 wrong direction, times 2, which is the value of that resistor, and then plus I3 going the right direction, I5 going the wrong direction. And you notice when I wrote my Vx equation, okay, we cared about this positive and this negative because we care if the voltage is dropping in a certain direction when finding out Vx. But for our sake here, I don't care. I don't care about Vx. I'm getting rid of this. I'm assuming I'm flowing through the right way, no matter what, okay? And if you can't wrap your head around that, and that is okay, you yourself could say, fine, I'm flowing through the positive end of Vx, so I'm just going to say plus Vx, okay? And you can do that. I didn't. I wrote plus I3 minus I5 times 8, and that happens to be equal to Vx. And you'll notice when we get to the 5th loop, I'll tell you something that would be opposite. But let's go to the 4th loop for now. So this, I start 4, sorry. I3 I started here. I4, we're going to start right here. And that's I4 going the right direction, I3 going the wrong direction through the 2 ohm resistor. And then there's no voltage associated here. So this one component has to equal 0. Okay, then the 5th loop. The 5th loop, I'm starting right here. Okay, so we're flowing negative terminal of a 12 volt voltage source and minus 12. And then we're flowing through right direction I5, wrong direction I2. So we're going to do I5 minus I2 times 6, the value of that resistor, and that's right here. And then here is where you could say, okay, I'm subtracting. So here you notice you're flowing through the negative terminal of that 8 ohm resistor, and you can care, okay? I'm saying if you care about the negative terminal and positive terminal Vx, okay? If you can't wrap your head around just ignoring that, then sure, you can say minus Vx. Or you can say, screw that, I don't care about Vx anymore. I already wrote my equation for Vx. I'm just going through a resistor. I'm going through the positive and out the negative, like always. And I've got my 5 ohm flow, my I5 flow in the right direction, I3 flow in the wrong direction across 8 ohm resistor. That's then plus I5 minus I3 times 8. And you'll notice that that's the same as negative Vx, right? This and this, these are opposites, okay? And that's going to then give you, of course, equal to 0. And those are all 8 equations you need to solve that problem. I know it's very long. It's kind of a treacherous equation to approach. It's a pain in the ass, but hopefully that was helpful. And I'm going to go through a second example where you just need to find the equations to find V2 now. Okay, so V2 in this problem, V2 is right here. So the first thing I'm going to do here is I went over here on the right and I wrote my V2 equation. And my V2 equation is I got I2 flow in the right direction, I3 flow in the wrong direction. Sorry, wrong. First thing I'm going to do is determine what direction I want my currents flowing in. And you'll notice I have them flowing counterclockwise. And that's because this 4 then is going, I4 is going in the right direction, the same direction as this 4 amp current source. So with that in mind, now I'm going to write my equation for V2, right? And just kind of work backwards. So V2 is, I've got I3 flowing in the right direction, I2 flowing in the wrong direction, so I3 minus I2 times the resistance. I times R is V, so that's I3 minus I2 times 50, okay? Then the next thing is, I've got an IX here. What the hell is IX? That's an unknown. Well, IX, if you'll notice, it's just the same thing as I2. There's no other, mesh here. There's no other loop that's countering I2, right? So this is just IX equals I2. And then the last thing is a simplification, because I said, well, I4 and this 4 amp current source are going in the same direction, they're equal. So I just wrote that in here. With that in mind, I can now start working on my meshes, because I have those kind of extra equations per se out of the way. So let's start working through mesh 1 or loop 1 if we can. And in loop 1, I tried to denote my starting positions like I did for that last example. We've got I1 flow in the right direction, nothing flow in the wrong direction through a 40 ohm source. Great. Then we're flowing through the negative terminal of a 50 volt source, minus 50. That has to all equal 0. Fantastic. Let's move on to I2. I'm going to start right here again. We're flowing through the positive end now of a 50 volt source, so add 50. Then over here, we're flowing through, ignore V2, okay? We're flowing through the right direction with I2, the wrong direction with I3 across a 50 ohm source, so that's I2 minus I3 times 50. Then we've got I2 flowing across a 5 ohm resistor and nothing flowing the wrong direction, that's I2 times 5. And then we can analyze our third loop, I3 going the right direction, I2 going the wrong direction across 50. Great. Then I3 going the right direction, I4 going the wrong direction across 10. Great. And then adding, because we're going through the positive terminal of 10IX plus 10IX, and that all has to equal 0. I forgot to write that in. Then this fourth loop, I4 minus I3, is going across this I4 in the right direction, I3 in the wrong direction, going across the 10. And that just has to equal 0 because there's no voltage associated with the 4 amp current source. Great. We have covered mesh current. Perfect. Now we're going to move on to superposition. I think superposition is literally the most useless crap ever. You will never use this in circuits. I'm sorry. I never used it. We only use it for quizzes. Your professor's going to teach it like it's the holy grail. And there's just a million different ways that you can solve currents without having to split it into like five different equations, right? You don't need to, I don't need to split do two analyses of my circuit. It's just kind of a waste of time in my opinion. But nonetheless, you're going to need to use it on a quiz, so I'm going to teach you superposition. The first step to superposition is you're going to deactivate sources, not really individually. I said individually here. What I mean is you're going to deactivate all current sources and keep all voltage sources active, and then you're going to deactivate all voltage sources and keep all current sources active. And then with all your current sources inactive, you're going to do node voltage. With all your voltage sources inactive, you're going to do mesh current, and then you're going to sum the effects of both of the sources, and then analyze whatever the question's asking you to analyze. So in this example, you're asked to find the power associated with the 6 ohm resistor. And essentially what that means is, well, you have Vx here that they've given you. You have to find Vx over 6 squared, right? Because power equals Vi. And so for voltage sources and current sources, you typically use this equation, maybe with a negative. But with resistors, well, you have an R value. So if you replace I with just V over R, then all you need to find is V. and it's V squared over R. And I meant to say, sorry. I'm so sorry. This is over 6, and this is squared, okay? So that's what you need to find. You need to find V squared over R. So in this left side, I've deactivated my voltage source. And when you deactivate a voltage source, it turns into a short circuit because voltage sources have zero resistance. Ideally, they have zero resistance, okay? Which means current can flow through them perfectly, all right? So it's shorted from here to here. It's just a wire. So now we're going to do mesh current. You'll notice I suggested that here. If you are deactivating your current source, if you're deactivating a voltage source, it has resistor 0, so it turns to a wire, and you do mesh current, okay? So let's do that. Mesh current around loop 1 is I1 across this 3, and nothing going in the wrong direction, and then plus I1 going the right direction, I2 going the wrong direction across 6, and all that has to equal to 0. And then in the right loop, we don't really need to analyze anything because you'll notice I2 I made in the right direction, the same direction of this 2 amp current source. So I2 is just equal to 2, wrote that in. And then Vx is equal to going through the positive terminal is I1, going through the negative terminal I2, so I1 minus I2 times 6. And that will allow you to calculate. You can do it on your own. Vx is equal to negative 4. And a lot of people would denote this as Vx prime, okay? And then in your second run, where you deactivate the current source, they'll call it Vx prime prime, okay? So now, let's analyze the other situation where we've deactivated our current source. You'll notice it's a short circuit, or it's not a short circuit, it's an open circuit because current sources have infinite resistance. I highlighted this earlier and I highlighted it in another one of my videos. Current sources have infinite resistance. They act as open circuits, okay? So we've deactivated it, it's an open circuit, and you'll notice everything on the right of this red does nothing. It's open, there's no current flowing through anything, right? So it's essentially null, and you just have a circuit that is a simple loop here. And people will do node voltage. Like I said, if it's more complicated, you can do node voltage. But here I'm noticing I just have a voltage source flowing through 2 resistors in series. I can do voltage division, which I taught you in my very first video. And that's Vn times the resistor we're analyzing over in ratio to the total resistance, and that gives you 8 volts. And we'll call that Vx prime prime. Why not? So now we have 8 volts and negative 4 volts, and adding those together gets our total Vx of 4 volts, okay? And remember, we want power. Power is V squared over R. That's 4 squared over 6 right here, because we're going across a 6 ohm resistor. And that's 16 over 6, which is 8 over 3, which is 2.2 2/3 watts, 2.67 watts. And that's going to be your final answer. Thank you very much for watching. I think our next topic's Thevenin equivalence. I can't remember, but I'll see you guys in the next one. Thanks for watching.